I want to briefly rehash exactly what we're trying to do and what the story has been so far. So, up until this point, we have been interested, and we're going to continue throughout the semester to be interested in hunting for population parameters, knowing that we never will actually know the true underlying value of those parameters. And they'll have some mean and some spread. Now, the mean may be a proportion, so it could be the percentage of Americans that approve of the president. It could be how much carbon is emitted, so it could be an actual number. It could be the wage gap for women in the US. Regardless, we're going to have some sample that's going to have a statistic, and we're going to want to make an inference to a population from that sample. A key element of our ability to do this is our creation of point estimates. Now, this is going to be a very wide classification in the sense that all a point estimate is some sample statistic that gives you a good guess about a population parameter. And every week, we're going to have to justify and talk about why we're using this as our best guess. Now, I haven't really talked about why means are a good way of describing the center. I'll justify that in a little bit, but remember that the point estimation for a population mean is going to be denoted with a hat of mu, and we can describe that population mean, our estimate for it, with the sample mean described by y bar. We can do the exact same thing with the population standard deviation. We're going to have a point estimate for what that is, and that point estimate, our best guess for that, is going to be the sample standard deviation. Now, like I said, a big question that we're going to be talking about throughout the semester is how do we choose among all the possible estimators, right? There could be many different ways that we characterize the center or a spread of some distribution if it's something that might be a little complex, like in a regression analysis. But regardless of what our estimator is, we generally want that to be unbiased in the sense that it's accurate. So if we have some expectation or the actual mean of what that population parameter is, we want that to be equal to mu, right? Like we want our prediction to equal the actual thing that it's supposed to be measuring with repeated sampling. We also want it to be efficient. We want it to be precise. We want to have the error around that point estimate to be smaller, right? We want our predictions to be better. Part of this is that our estimators are going to have to be consistent. That means as we increase the number of observations, the biasness or the accuracy that we have should increase as well, right? So just as a basic summary, the point estimates that we're going to use for our population parameters are mu and sigma. Our predictions for those, right, the point estimates are going to be hats. So sigma hat, mu hat. The best estimates that we have of those point estimates, right, are from our sample mean and our sample standard deviation. Now, I'm not doing too much in justifying this, but trust me for right now that they are the best in terms of bias and efficiency. Now, a key thing is that we are not assuming that the population is normal, right? All we're doing is assuming that, our estimate of mu, so our sample mean, is a sufficient guess at what the true population mean is as we increase not only the number of observations, but the number of samples.